Alright folks, so I'm going to be making this video just to make it a little bit easier for you if you couldn't quite figure out how to do percent composition based on the examples above. So we're going to do the first example. So if you look up here at example 2, we're trying to find the percent composition of copper bromide. So if you look down here, that's the exact thing we're doing. So in these problems, you're trying to find how much percent each thing in this compound takes up. So in this specific compound, we have 1 copper atom and 2 bromine atoms. So we're trying to figure out how much the copper constitutes and how much the bromine constitutes. So the first thing you want to do is try to figure out what the molar mass of copper bromide is. So hopefully you remember molar mass is where you take stuff from the periodic table, you take those weights, and you add them all up and get an overall weight. So here with copper bromide, we have 2 things. We have copper and we have bromine. Okay, so the weight of 1 copper atom is going to be 63.546, and the weight of 1 bromine atom is 79.904. But notice we have 2 bromines here, so I'm actually going to have to take this number and multiply it by 2 to get our overall weight. So really, the amount of bromine we have is about 159.808. So what we're going to do then is add up these 2 numbers, and we're going to get an overall mass. And that overall mass is going to be, let's see, 223.354. So that's my overall weight. So if you look up at the top in example 2, when you're trying to find the percent composition, you want to take the mass of each constituent and divide that by the total mass of the compound. So right now we have the total mass of the compound, so I'm going to circle that in blue so I remember what it is. So now what I want to do is try to figure out how much percent the copper takes up and the bromine takes up. So I'm going to do that over here on the side. So we take the mass of the copper in the compound, which is 63.546, and we're going to divide that by 223.354. Then, in order to get it to a percent, we're going to multiply by 100. So a lot of people will forget this step. You always want to make sure when you're trying to find a percent of something that you're multiplying it by 100, because really a percent is just a decimal that's been multiplied by 100. So when you do this math in your calculator, you take 63.546 divided by 223.354, you end up getting 28.45%. So I'm literally, that's my answer. That's how much copper is in this compound, 28.45%. Okay? Then we look at the bromine. Now we have 2 bromines in this case, so I'm going to take this number here in red, and I'm going to take 159.808, divide that by 223.354, and then multiply that again by 100. And what you end up getting with that answer is 71.549%. So what this means, what these numbers mean, is it tells you how much by weight this thing is composed of. So if I look at copper bromide, this isn't, actually it's copper 2 bromide, so it has those Roman numerals too. The copper in copper 2 bromide takes up 28.45% of the weight of the entire compound. The rest of the compound, 71.549% of it, is composed of bromine, so bromine's heavier. So when you're trying to find the percent compositions, all you're trying to do is figure out how much each constituent weighs in a percent, based on the total percentage of the entire compound, based on the whole amount of the entire compound. So, oops, didn't want to do that. This next part, I'm going to actually slide down because NaOH is pretty easy. You have sodium and oxygen and hydrogen. That one's not particularly difficult, so I don't really want to do that one as an example. Instead, oh no, I guess I have to go to the next slide. Instead, what I'd like to do is try number 3, which is a little bit challenging because now we've got some parentheses, okay? So again, we're trying to figure out how much each element has as a percent in this compound. So we're going to have nitrogen, we're going to have hydrogen, and we're going to have sulfur. Now notice this parenthesis here with this 2. That tells us we have 2 of everything that's in the compound. So that means I have 2 ammonias or 2 nitrogens and 8 hydrogens. Okay, so NH4 is ammonium, but we're looking at the actual atoms, the actual constituents of everything. So if I look at nitrogen, one nitrogen weighs 14.0067, but I have 2 of them. So I'm going to multiply that by 2, and I get 28.0134. I'm going to do the same thing for hydrogen. It weighs 1.00794, and I'm going to multiply that by 8 because that parenthesis makes it have 8 hydrogens. So that's 8.06352. And notice that I'm using a lot of decimal points. The reason why is because that's going to get me a more accurate answer. As long as you're in the ballpark of where the answer should be, I'm not going to take points off, but you really don't want to be rounding too terribly much because then you're going to get an answer that isn't very accurate. And then we only have 1 sulfur, so that's 32.066. So we're going to add up all of these things together, this guy and this guy and this guy, and the answer we get for our overall mass is 68.14292. So that's my overall mass. So now I have to figure out how much each thing weighs. So for nitrogen, we figured out it weighs 28.0134 because we have 2 nitrogens, and we want to figure out the percent composition of nitrogen in this compound, ammonium sulfide. So I take 28.0134, I'm going to divide that by 68.14292, which is the entire compound, and I'll multiply that by 100. When I do that in the calculator, the answer I end up getting is 41.109%. Okay, I'm going to do the same thing for hydrogen, so I'm not going to really talk through that. I'm just going to write it in here, and you can kind of watch me. My stylus isn't working, so that's great. Times 100, and we end up getting 11.83%. And finally, for sulfur, we have 32.066 divided by 68.14242. Sorry, it kind of is getting cut off, but you get the idea of what you should be setting this up like. Each setup looks almost exactly the same. You have the same number on the bottom. The number on the top is just how much you have of each substance, and that's going to be 47.0569%. So hopefully this tutorial has kind of shown you what I am expecting of you to know for percent composition. So essentially, when you're doing percent composition, you're just figuring out how much each atom is in the percent of the compound. So if the compound weighs, let's say, 100 grams per mole, and you have something that weighs 99 grams per mole and something that weighs 1 gram per mole, the thing that weighs 99 will be 99% of the compound by mass. So you're finding percent by mass of each thing in the compound. So just follow the steps that I've shown you. You want to do that each time. There's really no difference between any of these. Just the more you practice it, the easier it's going to get, and it's going to become kind of second nature. So I want you to go through this packet, make sure this is all done. For periods 3 and 4, this is going to be due on Thursday. For periods 6 and 7, this is going to be due on Friday. Okay?